Welcome back to Mr. DuPage's classroom. This lesson is for my Algebra 2 class. It is 4.1, Day 4 Notes, Exponential Function Word Problems. An exponential growth/decay model is A, which is right here, is our initial amount. A of t is the final amount, R is the growth or decay rate, and t is the time. So A plus or minus R is the growth or decay factor. Okay, this is literally no different than our A, B, X that we've been using. Okay, we're going to treat it exactly the same way. We just have to pick through some of the story problems in order to figure out what we are working with. Okay, something I want to talk about real quick before we get started though. 1%, how could I write that as a decimal? Well, 1% would be 0.01. Okay, 2% would be 0.02. 10% then would be 0.1. Something like 9.3% would be 0.093, and 0.3% would be 0.003. This is very important for us to know. You'll see why here in 1 second when it talks about the percentages and all that in the story problems. Okay? So let's read through the story problem, then we're going to talk through it piece by piece. The population of East Moline is 22,000. It's 22,000 people, and it increases by 4% each year. Write a model for the population of East Moline for any given year. All right. So the things that we are looking for, we're looking for the initial amount. What out of this story problem could possibly be our initial amount? Well, it talks about population of East Moline is 22,000. Well, I would say that's probably our initial amount. So A of t is just going to be basically like what we would write for y. A of t would equal 22,000. Okay? And it increases by 4% each year. So we've talked about A, we've talked about A of t. R is our growth/decay rate. This says increases by 4%. That to me sounds like a growth rate. It's talking about how much it grows percentage-wise each year. So what we're going to do is I'm going to have my parenthesis. 1. This plus or minus up here from our equation, if it is a growth, I'm going to use plus. If it is a decay or a decrease, then I'm going to use a minus. So this says increase. To me that sounds like growth, so I'm going to add. I have 4%. How would I write 4% as a decimal? 0.04. And then it says write a model. Well, this is a model. The only thing that's missing at this point is our t. And it did not give us a year that we need to worry about. It says in any given year. So what we're going to do is we're going to raise to the power of t. We don't know how many years it wants, so we're just going to raise to the power of t. All right. So then what I can do, though, is I can simplify inside of my parentheses here. So I'm going to keep it as 22,000. 1 plus 0.04 would be 1.04 raised to the power of t. That's all you have to do when it asks you to create a model. All right. All right, on to example 2. The United States has experienced a population growth of 9.7% since the 2000 census. If the population in 2010 was 308,745,538, what will the population be in 2020? What we're going to assume here is that our population growth is going to stay at 9.7% between 2010 and 2020. We're looking into the future, so we have to use previous growth models in order to figure this out. All right. So again, what we're going to do is A of t is going to be what we use for basically our y equals, right? We need to figure out what our initial value was. Well, our initial value is probably going to be this population right here, 308,745,538, okay? That is multiplied by our parenthesis. Remember, our parenthesis is 1. It's either going to be plus or minus depending on whether it's growth or decay. Well, in this case, we have the word growth in our problem, so it's going to be plus. How would I write 9.7% as a decimal? It would be 0.097. Okay? Now, t, in our last problem, we just used t because it didn't talk about a certain number of years. But in this problem, it says from 2010 to 2020, so I would have 10 years between those two, right? What I'm going to do now is I'm going to go ahead and simplify my parentheses. So I'm going to rewrite the rest of my problem and simplify my parentheses. So 1.097 raised to the 10th. Now, there's a couple different ways you can handle this. I could type all that through straight in my calculator and get an answer, or you could type 1.097, raise it to the 10th power, hit enter, then multiply that by the 308 million. Either way, you should come up with the same answer. What the answer is going to be, though, is 779,232,334.8. Now, we're talking about population, right? I can't have a partial person. So what I'm going to do is round to the nearest whole number. When I round to the nearest whole number, I'm going to round to this number here. So the 8 will tell me whether I will make it larger or smaller. Since it's bigger than 5, my approximate population would be 779,232,335 people. Okay? All right. Example 3. You bought a computer for $1,800. You expect the computer to lose value at a rate of 29% each year. Write an exponential model to represent the situation, then find the value of the computer after 2 years. Again, A of t is just going to be what we use for y equals, right? Now we need to find an initial value. Well, 1,800 is a pretty good initial value for us. It was the initial price of the computer, right? Now we're going to have 1. It's either going to be plus or minus, depending on whether it's an increase or decrease. It says it's going to lose value. So in this case, I'm going to subtract, right? At a rate of 29%. Remember that what I subtract from 1 is my rate. So 29% as a decimal would be 0.29. And I'm going to raise that to t. That is our model, right? Now that I have my model, I can go ahead and put 2 in for t. So it would be A of t equals 1,800. 1 minus 0.29. I'm going to go ahead and simplify that. So 1 minus 0.29 would be 0.71. I can put 2 in for t. Again, you could type that straight through in your calculator. Make sure you're using parentheses. Or you could take 0.71 raised to the second, hit enter, multiply it by 1,800. What you're going to end up with, A of t will equal 907.38, and we're talking about money. So the price of the computer after 2 years would be about half, $907.38, or $907.38, I'm sorry. Okay? Example 4. From the 2000 census to the 2010 census, Michigan was the only state to have a decrease in population. Given the state's population was 9,938,444 in 2000, and it has decreased by 0.6% since then, estimate the state's 2014 population. Estimate our 2014 population. So again, A of t is just like our y equals, right? I need an initial amount. This 9,938,444 looks good for an initial amount. I'm going to multiply that by 1. Plus or minus. We have to figure out whether it's plus or minus. Well, decreased would tell me that it's going to be subtraction. How can I write 0.06% as a decimal? Well, remember up here we talked about 0.3% is 0.003. So 0.6% would be 0.006. Now what we need to figure out is from 2000 to 2014. Okay? Well, 2000 to 2014 would be 14 years. If I go ahead and simplify my parenthesis, I would end up at 0.994 raised to the 14th. You can either type that straight through in your calculator, make sure you're using the parentheses, or I could take 0.994 raised to the 14th, multiply by my 9,938,444. When I'm done, well, let's write this down here to start with. When I'm done, I would have 9,135,404.39. Now again, this is population, so I can't have a partial person. Even if a person has lost a limb, lost the use of their legs, can't speak, they're still a full person, right? So A of t would be about 9,135,400. Remember, I'm going to round this to the nearest whole number, so this 4. So this 3 would tell me whether that 4 would go up or stay the same. In this case, I'm going to stay the same. Not a very large drop in the number of people. Only, let's see, it's only about, well, I guess it is a pretty big drop, 803,000 people. Okay. A quantity of insulin used to regulate body sugar in the bloodstream breaks down by about 5% each minute. Anytime you see a percentage sign, that's going to be your rate. A body weight adjusted dose is generally 10 units. Write a function representing the amount of the dose that remains after, about how much insulin remains after 12 minutes. So the first thing we need to do is write a function. So it's going to be the A of t would be equal to our initial amount. Do you think 5% is our initial amount? Probably not. I would say it's 10 units. Now I'm going to have 1. It's either going to be plus or minus, depending. This is saying breaks down. So if it's breaking down, I would say that it's going to be losing or decaying, right? So it would be 1 minus 5% would be 0.05 raised to the t. Now that we have our function, I can go ahead and put however long it's going to be in for t. Well, it told us it's going to be 12 minutes. So A of t would equal 10. Simplify your parenthesis. That would be 0.95 raised to the 12th. So my A of t would equal 5.4. Don't forget your label. It's going to be units. Well, that is the end of our lesson. The most important things here are to figure out exactly what your starting value is and figure out your growth rate or decay rate. Also, the story problem is going to tell you whether it's going to increase or decrease. If you can figure out those 3 things, it's going to be a pretty easy way of working through a story problem. We worked through it just like we did with linear growth or exponential growth or exponential decay. Well, thank you very much for watching this video. Remember that if you need any help, you need to come in and see me. Otherwise, have a great day.